Hi, welcome to Chemistry Unit 2, Level 2. This will be 2.2, and today we're learning IAIS on ions and isotopes. So first, let's look at Level 1. When we did Level 1, we had periodic table notation, which you see on the left, and then we had ion notation, but this ion notation looks kind of different. That's where Level 2 comes in. Notice on level 1 that we still did NP-NE, the name, the protons, the neutrons, and the electrons. However, because the notation, we got some different answers. So let's get started. An ion has a different number of electrons because it has a charge. So to find the number of electrons, you're going to take the atomic number minus the charge. So as far as notation is concerned, ion notation actually includes a number on the top right of the symbol. This is the charge. And the number of electrons is the atomic number minus the charge. Ions can only be identified in ion notation because if you're given periodic table notation or isotope notation, the number of protons and electrons will be the same. They won't have a charge given, so you won't have to change the number of electrons. An isotope has a different number of neutrons. It has a different mass. Remember in class how I talked about finding that one hydrogen atom that had a mass of 2? That hydrogen atom is an isotope of hydrogen. To figure out if something is an isotope, you have to do a comparison between the average atomic mass that's on the periodic table and the atomic mass that you're given in the problem. Looking at the notation, isotopes can be identified in ion or isotope notation. They will not match the rounded AAM from the periodic table. That's how you know you have an isotope. If you're given periodic table notation, the protons and the electrons will still be the same, okay? And the number of neutrons will not change either. Stable is the S. Remember we talked IAIS, and we'll go through what those exactly are. But S is stable. An atom that is not an ion or an isotope is stable. It matches the periodic table notation. Stable atoms can be identified in any notation. However, periodic table notation will always be stable. You'll have to check the others, compare them to what's given on the periodic table to see if they're stable or not. So here's your notation updates. Periodic table notation was our first notation. There was no change. Ion notation, you now have right here in the upper right-hand corner the charge, okay? And it will be a positive or negative number from -3 to +3, okay? Isotope notation has no change. Nothing is different about isotope notation. So level 1 stays the same, the way we found everything. Name goes with the symbol. Protons are equal to the atomic number. Neutrons are the atomic mass minus the atomic number. And this is the atomic mass that you're given in the problem. The electrons, if you remember, originally those electrons were equal to the atomic number. Now electrons will be the atomic number minus the charge if there is a charge. Level 2 is IAIS. The first I is an ion, and it's a yes or no question. Is there a charge? If there's a charge, you have an ion. The A is AAM. This is literally copy the average atomic mass from the periodic table. You can round it at this point if you want to make a comparison, but otherwise you just write the average atomic mass. The second I is the isotope. This question has to be answered yes or no. Is the AM given, the atomic mass given, different than the periodic table average atomic mass rounded? That's why we write down the average atomic mass, so that you can very easily make a comparison between what you're given and what is on the periodic table. The final S is stable. If both I's say no, stable will say yes. So let's look at this example. In this example, right, you're given K, 42, which is the atomic mass, 19, which is the atomic number, and -2, or 2 negative, it could be written forwards or backwards, is the charge. So now you have to answer these 8 questions. Its name is potassium. Potassium goes with K, K goes with potassium. There are 19 protons. That's the bottom left number. There are 23 neutrons. 42 minus 19 is 23. Please learn how to subtract without a calculator. The electrons are 21. 19 minus a 2 negative, or 19 minus -2, you do have to subtract it. Even though it's negative, you end up adding. Again, math. The electrons are 21. This is an ion because it has a charge. The AAM, got to go to my periodic table, actually look it up. The AAM for potassium is actually 39.1. So is this an isotope? Again, you have to ask the question, is 39.1 different than 42? Yes, it is, because they're not the same. They are different. So is it stable? No, it's not, because it is an ion and an isotope. Practice problem 1. Write it down, pause the video, see if you can do it on your own, and then come back and check. Okay, hopefully you figured out the name is lithium. Again, this is why we memorize these. There should be 3 protons, 5 neutrons, and 4 electrons. This is an ion. The AAM is 6.94. This is an isotope. It is not stable. How'd you do? Let's try another one. Practice problem 2. Again, you're going to want to write it down. Remember on the charge that if there is no symbol in front of it, no sign in front of it or behind it, it's a positive. Okay. So, pause the video, answer all 8, see how many you get. Its name is fluorine. There are 9 protons, 9 neutrons, and 7 electrons. 9 minus 2 is 7. This is an ion because it has a charge. The AAM is 19, therefore this is an isotope. It is not stable. Last practice. This is isotope notation. So remember, on isotope notation, you had to use the periodic table with it just to get what Mg's atomic number was. So pause the video, grab your periodic table, and do this one. All right, let's see how you did. This name is magnesium. There are 12 protons, because magnesium is number 12, 12 neutrons, because 24 minus 12 is 12, and 12 electrons, because there's no charge in isotope notation. This is not an ion. It can't be, because there's no charge in this notation. The AAM is 24.31. That rounds to be 24. That is the same, meaning not different, so it's not an isotope. If it's not an ion or an isotope, it essentially matches the periodic table. It is stable. Your assignments today have 12 problems that you're going to do. Good luck. Thanks for watching.